Geotrig, lesson 9, day 1. We got a few slides today. What we're going to talk about today is congruency. To be congruent. The last lesson talked about similarity. And if two things are similar, just meant that they what? They looked alike, right? Today we're going to take it a step further. We're going to actually talk about congruency. For two things to be congruent, what we're trying to say is that the two figures are geometrically equal. We gotta change here, go equal. They're the same. It means everything about them is equal. So it's more than a word of equal. They could have, when I think of equal in general, I'm thinking like, oh, they have the equal lengths. They have equal angles. So we kind of back up and say everything's the same, therefore it's congruent. But basically congruency means to be equal or to be the same in all aspects. Okay? Now it doesn't mean like all of the angles within an object are the same. It means that when two objects are congruent, you can find corresponding parts in the exact same places that are the same. Each one of these three different pairs are what we're going to say are congruent. The first ones up are line segments. What is the only defining thing about line segments?
They have 2 points.
Like they have 2 points, they start and stop, right?
Yeah.
But they have what trait? What do we say when, well, oh, that line segment, what are the twos represented, I guess, basically?
Length.
The lengths. Lengths are the only things that are the character trait of a line segment. So we can say that these two segments are congruent because they have the same length. Next up is the pair of angles. Guys, if this is 27 degrees and this angle is said to be 27 degrees, those two angles are
Similar.
congruent. They're equal. Guys, it does not matter because all angles that are 27 degrees are congruent. I don't care necessarily about how far your terminating and initial side lengths are. That's something different. But this whole idea that the angle here and that angle there are 27. So if I made an angle here and I called this 27 degrees, that angle is also congruent to those other two. It doesn't matter, okay? It doesn't matter the way it's opening, where it's facing, all of those things. And then we also have, it can be figures, geometric figures if you want, 2 triangles. Do you notice that both of these triangles are made up of 3, 4, and 5 side lengths? It also has a 90 degrees in the middle. And the cool thing about it is the angle between the 3 and the 5 in both triangles is the same. And the 5 and the 4 will also be the same. It's actually, this is the same photo, I flipped it. So they should be the same. Because it kind of makes sense that if I take a photocopy of something and stuck it somewhere else, they're exactly the same. This is different than similarity. Slight difference. And I'll hit upon this later. But kind of think back to our logic stuff. If I'm in Notre Dame Academy, I am in Green Bay. Correct?
Yeah.
It's different than to say, if I'm in Green Bay, then I am in Notre Dame Academy. because those two statements are not the same thing, are they? One of them implies the other, but the other one does not imply it, does it? Like if I'm in this school, I'm implying I'm also in Green Bay because the school lies within the boundaries of Green Bay. But if I cannot say it the other way around. Just because I'm in Green Bay does not imply that I will have to be in this school. So be very careful on that. Can I change the slide? So, this may be a little better way of saying congruency. I kind of hinted at this already. If I can pick something up, whether mentally or physically, I can flip it, turn it as necessary, I can put it back on top of some other figure, and they should match up completely. Angle for angle, side for side. If that is true, they are said to be the same thing. In math, we say they are congruent. Would you guys agree with this?
Yeah.
Okay. You don't have to write this. You can print this off and bring it in. Whatever you guys want to do. Guys, remember that similarity means? Similarity is things that look alike. They're different sizes, but they have the same angles. The reason I came up with that Green Bay and Notre Dame analogy is because of this line right here. Congruency is similarity, but it has a scale factor of 1. Guys, the problem we did in the beginning of class there from the last lesson wanted us to show similarity so that we can come up with that scale factor of xy over xm equals yz over my is because the scale factor between similar objects has to stay the same between all of their parts. But here's the thing. If something is the exact copy of another, should there be a difference in size? No. So if one side length is 5, its corresponding side length somewhere else will also be 5. And what's 5 divided by 5? 1. The scale factor is 1. It doesn't matter. If they are congruent, side to side, they will have the same length. Therefore, it's a multiple of 1. Doesn't change it. So, congruency implies similarity because all of the angles will be the same. But just because angles are the same does not mean that it is congruent. You have to take a step further and actually show that the ratio between the two is 1. So, we're going to talk about soon, not today, but tomorrow, proving two things to be congruent. And so we're going to have to write proofs, because if I say I can jump over cars, I would hope most people wouldn't just assume it to be true without me showing them. So we're going to have to prove things. Now, unfortunately, there are things that are going to be out of our scope and sequence, we'll call it, of things that we mathematically could prove at this level. So there are things that you're going to have to say, you know what, I have to just accept it to be true because my teacher or the book is saying it is. Because if we can do that collectively, we can use those things to show or prove a lot of other things. There are some that all of our math is posted on or is built off of. It's one of a lesson later on, and we'll talk about those later. So those things that are going to be past our scope and sequence, things that may be past where we could possibly do, and maybe some of them we can do, but we're just going to make it easier for us. We're going to use or call postulates. We assume true without proof. Example, Mr. Konchak's awesome. It's a postulate. You assume it's true. You don't need proof. So, you assume to be true without a proof. If we can accept that there will be a few things in this class that you just have to hold near and dear, it's going to allow us to show and develop our skills for a lot of other things. So, we're going to talk about some of these postulates, guys, some of these things. We got 1, 2, 3, 4, because we're going to lump these two together. So we got 4 of them that work and 1 that doesn't. We're going to talk about triangle congruency. When I said we're going to prove things to be congruent, a lot of those things are going to be triangles. Triangles are fairly relatively easy to work with. So, triangle congruency means showing 2 triangles are congruent. Okay. There are, started giving it up. SSS, SAS, ASA, which is the same as AAAS, HL, and the donkey postulate, which is a no-go.
Donkey.
What do you think SSS stands for? Side, side, side. Side, side, side. Now, I'm going to draw some triangles so we can demonstrate these. 2 identical triangles. If, guys, you can show that 2 triangles have side, 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 we can then say the 2 triangles are congruent. What do I mean? They share a side. I put a tick mark, right? They have 1 side in common. They have 2 sides in common. And if they have all 3 sides in common, they are congruent. Guys, actually, there's only one way to make a triangle with the side lengths 3, 4, and 5. It is the one that we had on the board earlier. A 3, 4, 5 triangle. It ends up being a right triangle of all things, and there's only one way to make it. Now, granted, 3 centimeters, 3 inches, 3 feet, whatever. But I'm saying if you had 2 triangles made from the same length, 3, a 5, and a 4, or 3, 4, 5, there would only be 1 triangle. Everybody's would look the same. What do you think SAS stands for? Side, angle, side. Now, for side, 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 it's not necessarily as important to recognize that I start at a side, I move to the next side, and then move to the last side because they're all the same. We only have 3 sides. It's important, though, when we're talking about side, angle, side, I have to start at a side that's congruent. Boom. Right? I got a side that's the same. I move to an angle that's next to that side. So I could say those angles are the same. And then rotating in the same direction, another side. Essentially, the angle is between 2 sides that are in the same places. Do you guys see that? So it's 2 sides with the included angle. The angle is in the middle of the sides that are congruent. That is side, angle, side. Congruent. What do you think ASA? Angle. Side. Angle. What do you think AAAS is?
Angle, 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 side.
Angle, 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 side. Correct. Guys, fundamentally, these are the same. And again, if I'm talking about what we just talked about, how they have to be all in a row, if I talk about an angle, a side, and then an angle again, they are congruent. But why is ASA and AAAS kind of lumped together here? Andy? Correct. If I know two angles in a triangle, then you also know the third one. Now there is a small technicality that the only way I would use the AAAS, okay, which would be this photo, this picture, right, is because I actually physically can look right there and see all of the angles are there. If I was given these two triangles, I will not use AAAS because does it show the third angles are the same? No, you can imply they are the same, but in proofs, guys, you need to show every step you make. Now, last one that works. Hypotenuse leg. It only works in right triangles. Only works in right triangles. If the hypotenuse, I forgot to leave some room here. Two triangles. It only works if we're talking about the hypotenuse and a leg. It only works in there. I can't stress that enough. And we don't have a donkey postulate. What's the only combination up there that we do not use? Angle, side, side. Angle, side, side is not used. So, we don't use angle, side, side. Yes, that is in the video. So, we do not use the donkey postulate. That does not prove two triangles to be congruent. Guys, have a great day.